Hello, in this lecture we'll find out the area of the green shape using two different methods. In the drawing we have a quarter circle, A or B is a quarter circle. Inside this quarter circle we have the green quadrilateral A O DC. And our mission is to find out the area of this green quadrilateral AODC. In addition, we know that side AC of the quadrilateral is equal to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Again, we have to find out the area of the green quadrilateral AODC. Okay, so first of all, because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees. And also, point O is the center of the circle that we can create by completing this quarter circle to a circle. Okay. So from the center of the circle, that is to say from point O, we'll draw perpendicular on chord AC. So actually, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. And here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. The center of this circle is here at point O. From point O we draw perpendicular OM on chord AB. That is to say this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And according to this rule number 11, the perpendicular OM to chord AB bisects chord AB. That is to say AM equals to MB. So whenever you draw perpendicular from the center of the circle to any chord, it will also bisect that chord. Here OM is perpendicular to chord AB, and therefore OM also will bisect chord AB. That is to say AM equals to MB. So we can actually implement rule number 11 in our drawing. Why? Because in our drawing we have from point O, that is the center of the circle, we draw perpendicular OP on chord AC. And according to rule number 11, the perpendicular OP will also bisect chord AC. That is to say, AP will be equal to PC. Okay, AP equals to PC according to rule number 11. AC in total is 24 according to what is given as the equation. Therefore, half of AC, AP is half of AC. That is to say, it must be equal to 24 over 2, that is 12. And the second half will, of course, also equal to 12 units. That is to say, AP equals to PC, each half equals to 12 units in its length. So the reason that AP equals to PC and each half equals to 12 is because we implemented rule number 11 in our drawing. Okay. In the next step, from point D, we will draw perpendicular on PO. Again, from point D, we will draw perpendicular on PO. So actually, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We will define the tangent point of the perpendicular from point D and PO as Q. So here we created actually quadrilateral PCDQ. In this quadrilateral PCDQ, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to what is given us in the question. The sum of 3 right angles is 90 times 3 is 270 degrees, plus this fourth angle. In total, they must be equal to 360 degrees according to the rule. Then the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, this missing angle must be equal to 90 degrees. Again, in order to complete the sum of the angles in this quadrilateral PCDQ to 360 degrees, the missing angle here must be equal to 90 degrees. So actually we found out that inside quadrilateral QPCD, we have 4 right angles. Therefore, we can relate to quadrilateral QPCD as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side PC must be equal to the opposite sides QD in rectangle QPCD. So PC equals to QD, but PC is 12, therefore QD must be also equal to 12 units in its length. Likewise, according to the same rule, in the same rectangle QPCD, CD must be equal to PQ, but CD is 7, therefore PQ must be also equal to 7 units in its length. Okay, in the next step we'll define the length of this line segment QO as X. We'll focus on the right triangle OQD. OQD is the right triangle because this angle equals to 90 degrees. And we define angle ODQ as alpha. We will continue to focus on the right triangle OQD. This angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. We will define 90 degrees minus alpha as beta. Therefore, the missing angle here must be equal to beta. What is the size of this angle, angle AOP? Angle AOP must be equal to angle AOB, that is 90 degrees minus beta. Again, 90 degrees minus beta must be equal to the missing angle here, angle AOP. So I write it down. The missing angle, angle AOP must be equal to 90 degrees minus beta. That is to say, it is equal to 90 degrees minus beta, but beta is 90 degrees minus alpha, therefore we can substitute beta here by 90 degrees minus alpha. Here we'll open the brackets of this expression and we get that 90 degrees minus 90 degrees is 0. And there we have minus times minus is plus. So in total this expression will be equal to alpha. So we found out that the missing angle AOP is equals to alpha. This is the missing angle AOP that is equal to alpha. In the next step we'll focus on the right triangle APO. On this right triangle APO, this angle equals to alpha. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of the angles in any triangle. Again, this angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha, according to our definition, equals to beta. So we can write down here that this angle equals to beta. In the next step, I will copy the right triangle OQD, the right green triangle OQD in a new page, and we find out the value of tangent alpha in this right triangle OQD. Side OQ equals to x according to our definition. Side QD, side QD, this is side QD, it is equals to 12 units. And this is angle ODQ, that is equals to alpha. So actually, this is the right green triangle OQD that I copied from the original drawing. In this right triangle OQD, we will get that tangent alpha equals to x over 12. Repeat again, in this right triangle OQD, we will get the tangent alpha equals to x over 12. In the next step, I will copy the right triangle OPA in a new page, and we find out the value of tangent alpha in this right green triangle OPO or APO. Angle AOP equals to alpha. Side AP of this green right triangle APO equals to 12 units. And finally, side PO, from the drawing it is very easy to see that side PO in total equals to 7 plus x. 7 plus x. So actually, this is the right green triangle APO that I copied from the original drawing. So in this right triangle APO, we'll get the tangent alpha equals to 12 over x plus 7, okay? Repeat again, in this right triangle APO, tangent alpha equals to 12 over x plus 7. So we have two different expressions for tangent alpha. Okay. In the next step, we will create equation number 3 that says that tangent alpha, according to equation number 1, must be equal to tangent alpha according to equation number 2. Okay. Tangent alpha according to equation number 1 equals to x over 12, and it must be equal to tangent alpha according to equation number 2, that is actually 12 over x plus 7. Okay, so here we cross multiply this equation and we get that according to equation number 3, x times x plus 7 equals to 12 times 12, that is 144. Here we'll open the brackets of this side of equation number 3, and we get that x times x is x squared plus 7x, that is equals to 144. Here we subtract 144 from this equation, and finally we get that x squared plus 7x minus 144 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we will find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. Now we'll put the data inside this formula for x in order to find out the value or the values of x in our specific quadratic equation. I will remind you that according to our definition, x is the length of line segment QO. Okay? So we want to find out the value of the length QO, that is x, according to our definition. So here we get that x equals to minus b. B is 7, so minus b is minus 7. Plus minus square root of b squared. B is 7, so b squared is 7 squared, that is 49. Minus 4 times a is 1, times c, that is minus 144 over 2a. A is 1, so it is 2 times 1, that is 2. So here we will get that x equals to minus 7 plus minus. And so inside the root we have minus 4 times minus 144 is plus 576 plus 49, in total it is 625. So inside the root we have to only with 625 over 2. So here we get that x equals to x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32 over 2. Minus 32 over 2 is minus 16. So finally we found out that x equals to minus 16. But because of the fact that x is a length, and the length must be a positive number, we'll cancel this solution for x that is a negative number, and we're left only with the second solution that is possible for x. The second solution for x is that x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So finally, according to the second solution, we found out that x equals to 9 units in its length. This line segment QO equals to x, and x equals to 9 units in its length. So this line segment QO equals to 9 units in its length. So our mission is to find out the area of the green quadrilateral ACDO. In order to find out the area of this green shape, we divide the green shape into 3 parts. And then we'll find out the area of each part separately, and then we will add the 3 areas with each other, and this will be, of course, the area of this green shape. The first part that we will divide the green shape is the area of the green right triangle APO. We'll define the area as A1. The second part of the this green shape will be the area of the right triangle OQD. We will define the area of OQD as A2. And finally, the third part that we divide this green shape is the rectangle PCQD. We define the area of rectangle PCQD as A3. It is very clear from the drawing that the total area of the green shape must be equal to A1 plus A2 plus A3. So I write it down. The area of the green shape must be equal to A1 plus A2 plus A3. In the next step, we'll calculate each area separately, and then we'll add the 3 areas with each other. This will be, of course, the area of the green shape. So A1 is the area of the green right triangle APO. So I'll copy the green triangle APO in the new page, and we find out the area of this green triangle. We've already found out that x equals to 9. Okay. We use the fact that x equals to 9 in order to calculate the length of side PO. This is the green right triangle APO that I call it from the original drawing. Side AP equals to 12 units in its length. Side PO in total equals to 7 plus x. I repeat again, PO in total equals to 7 plus x, and x is 9, therefore PO in total equals to 7 plus 9, that is 16. The length of this side PO is 16 units. So, repeat again that A1 is the area of this right triangle APO. The area of this right triangle APO must be equal to AP times PO over 2. Okay. AP is 12 times PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12. That is actually 96 square units. So we found out that the area of this right triangle APO, that is A1 actually, is equals to 96 square units. In the next step we will find out the area of A2. A2, it is actually the area of the green right triangle OQD. So I'll copy this right triangle OQD in the new page, and we find out the area of this green right triangle OQD. So this is actually triangle OQD. Is the coordinates of the original drawing. Side OQ equals to x and x equals to 9, so OQ equals to 9. Side QD equals to 12 units. So actually the area of this right triangle OQD must be equal to OQ times QD over 2. OQ is 9, QD is 12 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54. In conclusion, found out that A2 equals to 54 square units. That is actually the area of this right triangle OQD. Okay. And finally, we'll find out the area of the rectangle. That will be A3 actually. A3 is the area of rectangle PCDQ. Okay, the area of a rectangle is equals to the length of the rectangle times the width. The length is PC and the width is PQ. Okay, so the area of the rectangle PCDQ is PC times DQ. PC is 12 and PQ is 7. 12 times 7 is 84. In conclusion, we found out that A3 equals to 84 square units. I'll repeat again that the total area of the green shape equals to A1 plus A2 plus A3, so I write it down. We have already found out that A1 equals to 96 square units, plus A2 that is equals to 54 square units, plus A3 that is equals to 84 square units. 96 plus 54 it is 150, and 150 plus 84 is 200, 24, 200, 34 square units. So found out in conclusion that the area of the green shape equals to 234 square units. In the next step, I will present to you how to find out the area of this green shape according to the second method. In the second method, we'll join points A and D together by a straight line. By joining points A and D, we created the right green triangle ACD. In the next step, we will implement on this right green triangle ACD the Pythagoras theorem in order to find out the length of the hypotenuse AD. So I copy the right green triangle ACD in the new page, and we will implement on it the Pythagoras theorem. So actually, this is the right green triangle that I copied from the original drawing. Side AC equals to 24 units, and side CD equals to 7 units. By PT is the abbreviation for Pythagoras theorem. In this right triangle, according to the Pythagoras theorem, we will get that AD square equals to AC square plus CD square. Okay, so AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus CD square. CD is 7, therefore CD square is 7 squared, that is 49. So AD square equals to 576 plus 49 is 625. Here we take a root out of this equation, and finally we get that AD equals to the square root of 625, that is actually 25. So we actually found out that the length of the hypotenuse of the right green triangle ACD is equals to 25 units. Okay. In the next step, we will do a construction. We will complete the quarter circle to a circle. Because of the fact that AOB is a quarter circle, angle AOB must be equal to 90 degrees, and point O must be the center of the circle that we will create by completing this quarter circle to a circle. Okay. So we completed this quarter circle to a circle. Point O is the center of the circle, point A is the point of the circle itself. Therefore OA is the radius of this circle. We will define the radius of this circle as R, therefore OA must be equal to R. In the next step, we will extend the radius AO by a straight line until it touches the circle, and we will define the touching point of the extended radius AO and the circle as M. Here point O is the center of the circle, point M is the point of the circle itself, therefore OM is also the radius of this circle, that is equal to R according to our definition. So AM, chord AM passes from point O, that is the center of the circle. Any chord that passes from the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle. What is the length of AM? From a drawing it is very easy to see that AM equals to R plus R, that is 2R. In conclusion, we found out that AM is the diameter of this circle, and this is equals So it is twice as long as the radius, that is to say it is equals to 2r, and that is what we expect from any diameter. It must be twice as long as the radius. Exactly as we found here. In the next step, we will extend side CD by a side line until it touches the circle, and then we will ask where the extended side CD will touch the circle. We will assume that the extended side CD will not touch the circle at point M, but in any other point, for example, at this point, point N. Anyway, we know that peripheral angle ACN must be equal to 90 degrees because angle ACD equals to 90 degrees. We just extended side CD by a straight line. When you extend one leg of the angle by a straight line, you didn't change the size of the angle. It must be still 90 degrees. We just extended the leg by a straight line, so we never changed the size of the angle. Therefore, it's still, even peripheral angle ACN, still must be equal to 90 degrees. So here we actually created peripheral angle ACN that is equal to 90 degrees. But it is impossible that peripheral angle ACN that is equal to 90 degrees, it rests on AN. It contradicts rule number 5. Why? Because according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here, peripheral angle MAN equals to 90 degrees. And therefore, according to this rule number 5, this peripheral angle MAN must rest on MN. And indeed, here, MN is the diameter of the circle. Therefore, because of the fact that peripheral angle ACN also equals to 90 degrees, it must rest on AN, that is the diameter of the circle. But it is actually rest on AN, and AN is not the diameter of the circle. It contradicts rule number 5 because according to rule number 5, this peripheral angle ACN that is equal to 90 degrees must rest on AM. But it is actually rest on AN that is not the diameter of the circle. And due to the fact that according to our assumption that the extended side CD will touch the circle at point N, if it touches the circle at point N, then we get contradiction to rule number 5 because according to rule number 5, this peripheral ACN must rest on AM that is the diameter of the circle. But according to our assumption that the extended side CD will touch the circle at point N, it rests on AN that is not the diameter of the circle. Therefore, we must conclude from it that our assumption that the extended side CD will touch the circle at point N is not true, is not correct. And we must conclude from it that the extended side CD will touch the circle at point M and not in any other point. In this way, we will avoid contradiction to rule number 5. Why? Because if the extended side CD will touch the circle at point M, then we will have peripheral angle ACM that is equal to 90 degrees, and this peripheral angle ACM rests on AM. That is the diameter of the circle, exactly according to rule number 5. Okay, so the extended side CD must touch the circle at point M. In this way, we will avoid contradiction to rule number 5. Actually, this moment obeys rule number 5 because we have peripheral angle ACM that is equal to 90 degrees, and indeed, this peripheral angle ACM that is equal to 90 degrees, it rests on AM that is the diameter of the circle, exactly according to rule number 5. So we can say that we extended side CD by a straight line, therefore CDM is one straight line. Okay, in the next step, we will focus on this side of the straight line AM at point O. Which angles we have at this side of AM at point O? We have this angle that is equal to 90 degrees plus this missing angle. In total, they must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay, so 90 degrees plus the missing angle must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. In the next step, we will prove that the green right triangle AOD is congruent to the white right triangle MOD. So I write it down. The green right triangle AOD is congruent to the white right triangle MOD. So why those two right triangles congruent to each other? First of all, AO equals to OM. Repeat again. Side AO of the green triangle equals to side OM of the white triangle. They are both the radii of the circle, therefore they are equal to each other. In addition, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle AOD in the green triangle equals to this angle, that is angle MOD in the white triangle. Repeat again. Angle AOD in the green triangle equals to angle MOD in the white triangle. They are both equal to 90 degrees, therefore they are of course equal to each other. And finally, DO, side DO is a common side that belongs to both triangles, so we can write down that side DO equals to itself. Repeat again, DO equals to DO. DO is a common side that belongs to both triangles. So actually we proved that the green right triangle AOD is congruent. This is the sign of congruent to the white right triangle MOD according to side angle side rule. I'll explain what I mean. We actually proved that those two sides and the angle between them are correspondingly, in the green triangle, are corresponding equal to those two sides and the angle between them in the white triangle. Therefore, we actually proved that those two right triangles can go into each other according to side angle side rule. Two sides and the angle between them in the green triangle are corresponding equal to those two sides and the angle between them in the white triangle. And from the fact that those two right triangles can go into each other, we will derive that side AD in the green triangle equals to side DM in the white triangle. AD equals to DM. AD equals to DM. AD equals to DM according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides AD and DM must be also equal to each other. But AD equals to 25, so we can write here that AD equals to 25 units in its length. And from this equation 25 equals to AD equals to DM, we will derive that DM also equals to 25 units in its length. This side DM equals to 25 units in its length. And therefore, because of the fact that CDM is one straight line, it means that CM in total must be equal to CD plus DM. So CM equals to CD, that is 7, plus DM, that is 25. 25 plus 7 is 32. So in total CM equals to 32 units in its length. AC equals to 24 units in itself, and AM is the diameter of the circle that is equal to 2R. So we will implement, I will copy the right triangle ACM in a new page, and we will implement on this right triangle ACM the Pythagoras theorem. So actually, this is the right triangle ACM that I copied from the original drawing. It's according to what is given in the question. AC equals to 24. We just right now found out that CM in total equals to 32. This angle equals to 90 degrees according to what is given in the question. AM is the diameter of the circle that is equal to 2R. Now here by PT is the relation for Pythagoras theorem. In this right triangle ACM, according to the Pythagoras theorem, we'll get that AM squared equals to AC squared plus CM squared. Okay? AM is 2R, therefore AM squared is 2R squared, that is 4R squared. And it equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So 4R squared equals to 576 plus 1024 equals to 1600. Okay? Here we will divide this equation by 4, and we get that R squared equals to 1600 over 4 is 400. Here we take a root out of this equation, and finally we get that R equals to the square root of 400, that is 20. So we found out that the radius of this circle R, it is equals to 20 units in its length. So in the next step, I will copy the right triangle AOD in the new page, and we will implement in this right triangle AOD the Pythagoras theorem in order to find out the length of the missing side OD. Okay, so here we're talking about the right triangle AOD. AO equals to 20 units in its length. It is the radius of the circle. The hypotenuse AD equals to 25. So actually, this is the right triangle AOD that I copied from the original drawing. By PT is a version for Pythagoras theorem, and this right triangle AOD, according to the Pythagoras theorem, we will get that AD squared equals to AO squared plus OD squared. Okay. So AD squared, AD is 25, therefore AD squared is 25 squared, that is 625, and it is equals to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400 plus OD squared. OD is the missing side, so we leave it as it is. Here we subtract 400 from this equation, and finally we get that 625 minus 400 is 225. That is equals to OD squared. Here we take a root out of this equation, and finally we get that OD equals to the square root of 225, that is actually 15. So we actually found out that the missing side OD equals to 15 units. Our mission is to find out the area of this green shape. We divide this area into two parts. The first part will be the area of the right green triangle AOD, that we will define this area as A1. The second part will be the area of the green right triangle ACD. We will define this area as A2. It is very clear from the drawing itself that the total area of the green shape equals to the sum of the areas of those two right triangles, the right triangle AOD plus the right triangle ACD. That is to say, the total area of the green shape equals to A1 plus A2. So I write it down. The area of the green shape equals in total to A1 plus A2. A1 is the area of the green triangle AOD, so I copy the green triangle AOD here and we find out the area of this green right triangle AOD. So actually, this is the green right triangle AOD that I copied from the original drawing. According to our definition, A1 is the area of this green triangle, right triangle AOD. So the area of this right triangle AOD must be equal to OD times AO over 2. OD is 15 times AO times AO, that is 20 over 2. 15 times 20 is 300, and 300 over 2 it is 150. So if we found out that A1, that is the area of this right triangle, it is equal to 150 square units. In the next step, we will find out the value of A2, that is actually the area of the green right triangle ADC. So I copy the green right triangle ACD in the new page and we find out the area of this right triangle. So actually this is the green right triangle ACD that I copied from the original drawing, and this is actually A2 according to our definition. The area of this right triangle ACD must be equal to AC times CD over 2. AC is 24 times CD is 7 over 2. 24 over 2 is 12, so in total this expression equals to 12 times 7, that is 84. So in conclusion, we found out that A2 equals to 84 square units, that is the area of the right triangle ACD, and we already found out that A1 equals to 150 square units, that is the area of the right green triangle AOD. As I already mentioned before, in total the area of the green shape is equal to A1 plus A2. A1 is 150, A2 is 84. 84 plus 150 equals to 234. In conclusion, we found out that according to the second method also, the area of the green shape in total it is equal to 234 square units. In the next step, I summarize the lecture. We start with the first method, of course. In this lecture, we found out the area of this green quadrilateral AODC. It is given us the question that AOB is a quarter circle. Side AC of the quadrilateral equals to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral ACOD. Because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees. And this point O is the center of the circle that we can create by completing this quarter circle to a circle. Okay, so in the next step we did the construction, that is to say from point O, that is the center of the circle, we do perpendicular on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. Then I presented to you rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O we do perpendicular OM to chord AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. According to this rule number 11, the perpendicular OM also bisects chord AB. That is to say, AM equals to MB. So we can implement rule number 11 in our drawing. Why? Because in our drawing we have from point O, that is the center of the circle, we do perpendicular OP on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And according to rule number 11, the perpendicular OP also bisects chord AC. That is to say, AP equals to PC. But AC in total equals to 24 units. Therefore, each half, AP and PC, must be equal to 24 over 2. That is 12. So AP equals to 12 and PC also equals to 12 according to rule number 11. Then from point D we do perpendicular on PO. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO as Q. So inside quadrilateral PQDC we have 1, 2, 3 right angles. This angle equals to 90 degrees according to what is given us in the question. The sum of 3 right angles is 90 times 3 is 270 degrees. Plus this fourth angle, in total they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore the missing angle must be equal to 90 degrees. In order to complete the sum of the angles in this quadrilateral to 360 degrees, the missing angle must be equal to 90 degrees. So inside quadrilateral PQDC we have 4 right angles. Therefore we will relate to quadrilateral PQDC as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, CD equals to PQ and rectangle PCDQ. But CD is 7, therefore PQ must be also equal to 7 units in its length. Likewise, in the same rectangle PCQD, we get that according to the rule that the opposite sides are equal to each other, the opposite sides of a rectangle are equal to each other, we get that PC equals to QD. But PC is 12, therefore QD must be also equal to 12 units in its length. Then we defined the length of right segment QO as X, and we focus on the right green triangle OQD. In this right green triangle OQD, this angle, we define this angle as alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. So this angle, the missing angle, so I already mentioned 1 minute ago that this angle must be equal to 90 degrees minus alpha. We defined 90 degrees minus alpha as beta, therefore this angle equals to beta. Then we found out the value of the missing angle, angle AOP. What is the size of this angle? Must be equal to the big angle AOB that is equal to 90 degrees plus this angle beta. So 90 degrees minus beta equals to the missing angle AOP. Angle AOP equals to 90 degrees minus beta. But beta, according to our definition, equals to 90 degrees minus alpha. So we can substitute beta here by 90 degrees minus alpha. Then we open the brackets here, and we got here that 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total, this expression equals to alpha. In conclusion, found out that the missing angle, angle AOP, equals to alpha. Angle AOP equals to alpha. Then we focus on the right green triangle APO. In the right green triangle APO, this angle equals to alpha. This angle equals to 90 degrees according to our construction. Therefore, the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is beta, so I can write it that this angle equals to beta. Then I copied the right green triangle OQD in a new page. And I found out the value of tangent alpha in this green right triangle OQD. This is the right green triangle OQD that I copied from the original drawing. OQ equals to x according to our definition, or QO equals to 12 units in itself, angle QOB equals to alpha. In this right triangle OQD, it is very clear from the drawing that tangent alpha equals to x over 12. This is equation number 1, tangent alpha equals to x over 12. Then I copied the right green triangle APO in a new page, and we found out the value of tangent alpha in this right green triangle APO also. This is the right green triangle APO that I copied from the original drawing. Inside the AP equals to 12 units in its length. What is the length of PO? From the drawing it is very easy to see that PO in total equals to 7 plus x. Okay, it is equal to 7 plus x. So we can write here that PO equals to 7 plus x, and this is angle alpha. In this right triangle APO, we will get the tangent alpha equals to 12 over x plus 7. Again, tangent alpha equals to 12 over x plus 7. So we have two different equations for tangent alpha. Then we created equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 is x over 12, and it must be equal to tangent alpha according to equation number 2. That is actually 12 over x plus 7. Here we cross multiply this equation and found out that x times x plus 7 equals to 12 times 12, that is 144. Here we open the brackets on this side of equation number 3 and found out that x times x is x squared plus 7x, that is equals to 144. Here we subtract 144 from this equation and finally found out that x squared plus 7x minus 144 equals to 0. So this is a quadratic equation. And the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. When we find out the value of x according to the following formula, that x equals to minus b plus minus the square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0. The coefficient A equals to 1, the coefficient B equals to 7, and the coefficient C equals to minus 144. Now what is left to do is to put the data inside the equation for x, and we will find out the value of the values of x. I will remind to you that according to our definition, the length of line 7QO is x. So we put the data inside the equation for x, and we found out that x equals to minus b. B is 7, so minus b is minus 7, plus minus the square root of b squared. B is 7, so b squared is 7 squared. That is 49, minus 4 times a is 1, times c is minus 144, over 2a. A is 1, so 2 times 1 is 2. So here we have x equals to minus 7 plus minus inside the root, we have minus 4 times minus 144 is plus 576, plus 49, in total it is equal to 625. So inside the root, we left only with 625. And I found out actually that x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So in conclusion, found out that according to the first solution for x equals to minus 16. But because of the fact that x is the length, and the length must be a positive number, we cancel the solution for x that is a negative number. So we left only with the second solution that is possible for x, that x equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So in conclusion, found out that x equals to 9 units in its length. The length of this 9 segment QO that is x is 9 units. And then we have here a complete, so we actually divided the green shape into 3 parts. The first part is the right green triangle APO. We define the area of this green right triangle APO as A1. The second part that we divided the green shape is the area of the green right triangle QOD. We defined this area as A2. And finally, the third part that we divided this green shape is the rectangle PCQD. And we define the area of this rectangle as A3. It is very clear from the drawing that the total area of the green shape must be equal to A1 plus A2 plus A3. That's actually the sum of the areas of the two right triangles plus the area of the rectangle. So I repeat again, the area of the green shape in total must be equal to A1 plus A2 plus A3. A1 is the area of this green right triangle APO. I copy the green right triangle here. Side AB equals to 12 units, PO equals to x plus 7. But x is 9, so PO equals to 9 plus 7, that is 16. And here, the area of this right triangle APO equals to AP times PO over 2. AP is 12, PO is 16 over 2. 16 over 2 is 8, so in total this expression equals to 8 times 12, that is 96. So I actually found out that the area of this right triangle APO equals to 96, and this is, according to the definition, this is A1. A1 equals to 96 square units. Then we found out the value of A2. A2 is the area of the green right triangle OQD. So I copied the green right triangle OQD here, and we found out the area of this right triangle. QD equals to x, and x is 9. Actually OQ equals to x, and x is 9, and QD equals to 12 units. So the area of this right triangle OQD must be equal to OQ times QD over 2. OQ is 9, QD is 12 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54. So actually found out that A2, that is the area of this right triangle OQD equals to 54 square units. And finally we found out the area of rectangle PCDQ. The area of any rectangle is the length of the rectangle times the width. The length is PC, the width is PQ. So PC is 12 and PQ is 7. 12 times 7 is 84. So in conclusion, I found out that the area of the rectangle that is A3, according to our definition, it is equal to 84 square units. And again, I repeat again that the total area of the green shape equals to A1 plus A2 plus A3. A1 equals to 96 square units. A2 equals to 54 square units, and finally A3 equals to 84 square units. Again, A1 equals to 96 units, A2 equals to 54 square units, and A3 equals to 84 square units. 96 plus 54, it is 150, and 150 plus 84 in total is equal to 234 square units. So I found out actually that the area of the green shape in total equals to 234 square units. We finished with the first method, then I presented to you how to find out the area of this ring shape according to the second method. In the second method, we joined points A and D together by a straight line. In this way, we created the right green triangle ACD. Then we implemented the Pythagoras theorem on this right triangle ACD in order to find out the length of the hypotenuse AD. This is the right green triangle ACD that I copied from the original drawing. Side A equals to 24 units and side CD equals to 7 units according to what is given us the question. This angle equals to 90 degrees according to what is given us the question. So according to the Pythagoras theorem, in this green right triangle ACD, AD squared equals to AC squared plus CD squared. So AD squared equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CD squared. CD is 7, so CD squared is 7 squared, that is 49. So AD squared in total equals to 576 plus 49, that is 625. We took a root out of this equation and finally found out that AD equals to the square root of 625, that is 25. So I found out that the length of the hypotenuse AD of the right triangle ACD equals to 25 units in its length. Then we complete, first of all, because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees, and point O is the center of the circle that we will create by completing this quarter circle to a circle. We actually completed this quarter circle to a circle. Point O is the center of the circle, point A is the point of the circle itself, therefore AO is the radius of the circle that we defined as R. Then we extended the radius AO by straight line until it touched the circle at point M. So AM is a chord that passes for the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore AO is the diameter of the circle. Here point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle, that is equal to R. So AM in total equals to R plus R, that is to R. In conclusion, you can say that AM is the diameter of the circle, that is equal to 2 times the radius. Then we extended side CD by a straight line until it touches the circle. Our assumption was that it will not touch the circle at point M, but in any other point, for example this point, point N. It's given us the question that angle ACD equals to 90 degrees. We have never changed this angle is equal to 90 degrees, we just extended the leg of the angle. When you extend the leg of the angle, you never change the size of the angle, but only the length of the side of the leg. So angle ACN, still it is equal to 90 degrees. Peripheral angle ACN still will be equal to 90 degrees. But here we have contradiction to rule number 5. Why? Because according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. MN is the diameter of the circle, and peripheral angle MAN that is equal to 90 degrees indeed rests on MN, that is the diameter of the circle. But here ACN, angle ACN is a peripheral angle that is equal to 90 degrees, but it doesn't rest on AM, it rests on AN. That is not the diameter of the circle. But according to rule number 5, peripheral angle ACN that is equal to 90 degrees must rest on AM. But actually it rests on AN and not on AM, that is the diameter of the circle. This is contradiction to rule number 5. Therefore, our assumption that the extended side CD will touch the circle at point N is not correct, because it contradicts rule number 5. Because AN is not the diameter of the circle, but this peripheral angle that is equal to 90 degrees must rest on AM, that is the diameter of the circle. So in order to avoid that contradiction, we must conclude that the extended side CD will touch the circle at point M and not in any other point. Otherwise, you have contradiction to rule number 5. So if the extended CD will touch the circle at point M, then we will not have any more contradiction to rule number 5. Why? Because according to rule number 5, this is peripheral angle ACM that is equal to 90 degrees, and indeed this peripheral angle ACM that is equal to 90 degrees, indeed it rests on the M that is the diameter of the circle. Exactly according to rule number 5. So we extended side CD by side line, therefore CDM is one side line. Then, if you focus on this side of the straight line AM, at point O, the sum of the angles here must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at this side of AM? At point O, we have this angle that is equal to 90 degrees, plus the missing angle. In total, they must be equal to 180 degrees, according to the rule that I mentioned. Therefore, this angle must be equal to 90 degrees. Then we proved that the green right triangle ADO is congruent to the white right triangle MOD. But those two right triangles can go into each other. First of all, side AO of the green triangle equals to side OM of the white triangle. AO equals to OM, they are both the radii of the circle, therefore they are equal to each other. In addition, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. Repeat again, angle AOD in the green triangle equals to angle MOD in the white triangle, they are both equal to 90 degrees, therefore they are equal to each other. And finally, side DO is a common side that belongs to both triangles, so side DO equals to itself. DO equals to itself is a common side that belongs to both triangles, so actually succeeded to prove that the green right triangle AOD is congruent to the white right triangle MOD according to side angle side rule. We'll see what I mean. Those two sides and the angle between those two sides in the green triangle are corresponding equal to those two sides and the angle between those two sides in the white triangle. Therefore, those two triangles can go into each other according to side angle side rule. And from the fact that those two right triangles can go into each other, we will derive that side AD in the green triangle equals to side DM in the white triangle. And repeat again, side AD equals to side DM according to the rule that corresponding sides in the one triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say AD and DM, must be also equal to each other. But AD equals to 25. So we can write here that AD equals to 25, and from this equation 25 equals to AD equals to DM, we will derive that DM also equals to 25 units in its length. This side DM equals to 25 units. CDM is one side line, therefore CDM in total must be equal to CD plus DM. That is to say, CDM equals to CD, that is 7, plus DM, that is 25. In total, CDM equals to 25 plus 7, that is 32. So CM in total equals to 32 units in its length. Then I copied the right triangle ACM in a new page and implemented Pythagoras theorem on this right triangle ACM. Side AC, this is the right triangle ACM that I copied from the original drawing. Side AC equals to 24 units in its length. We just right now found out that side CM equals to 32 units. The hypotenuse AM is the diameter of the circle that is equal to 2R. According to the Pythagoras theorem, in this right triangle ACM, AM square equals to AC square plus CM square. AM square equals to AC square plus CM square. So AM is 2R, therefore AM square is 2R squared, that is 4R squared. This is equal to AC square. AC is 24, therefore AC square is 24 squared, that is 576 plus CM square. CM is 32, therefore CM square is 32 squared, that is 1024. 576 plus 1024 it is equal exactly to 1600, so we found out that 4R squared equals to 1600. We divided this equation by 4 and finally found out that R squared equals to 400. Then we took a root out of this equation and finally found out that R, the radius of this circle, equals to 20 units. The radius of this circle equals to 20 units in its length. Then I copied the right triangle AOD in a new page and implemented the Pythagoras theorem on this right triangle AOD in order to find out the missing side, side OD. This is the right triangle AOD that I copied from the original drawing. We implemented the Pythagoras theorem in this right triangle. According to the Pythagoras theorem, this right triangle AOD, AD squared equals to AO squared plus OD squared. AD is 25, therefore AD squared is 25 squared, that is 625, and this is equal to AO squared. AO is 20, therefore AO squared is 20 squared, that is 400, plus OD squared. OD is the missing side, so we leave it as it is. We subtracted 400 from this equation, and finally found out that 625 times 400 is 225, so 225 equals to OD squared. We took out of this equation, and finally found out that OD equals to the square root of 225, that is 15. So the missing sign here, OD equals to 15 units in its length. Then we divided the area of the green shape into two parts. The first part is the area of the green right triangle AOD. We defined it as A1, and the second part is the area of the green right triangle ACD. We defined it as A2. It's very clear from the drawing that the total area of the green shape must be equal to A1 plus A2. Repeat again, the total area of the green shape equals to A1 plus A2. A1 is the area of the right triangle AOD. I copied it here from the original drawing. AO equals to 20 and OD equals to 15. So the area of A1, that is the area of the right triangle AOD, must be equal to AO plus OD over 2. AO is 20, OD is 15 over 2. 15 times 20 is 300, and 300 over 2 is 150. So I found out in total that A1 equals to 150 square units. Then found out the area of A2. A2 is the area of the right green triangle ACD. So I copied the right green triangle ACD in a new page, and found out the area of this right triangle ACD. The area A2 is the area of the right triangle ACD. The area of this right triangle ACD equals to AC times CD over 2. AC is 24, CD is 7 over 2. 24 over 2 is 12, so in total this expression equals to 12 times 7, that is 84. So in total, the area of this right triangle ACD, this is A2, this equals to 84 square units, and we have already found out that A1 equals to 150 square units. The total area of the green shape equals to A1 plus A2. A1 is 150 and A2 is 84. 150 plus 84 is 234. So we found out that the area of the green shape in total equals to 234 square units. That is exactly the result that we got in the first method. Okay, so the area of this green shape equals to 234 square units. In both methods we arrived to the same result. Okay, thank you very much.